Hello, Namaskar. Myself Professor Jaimala, Department of Mathematics, Chaudhry Charan Singh University, Meerut. I am here with my lecture on mechanics. This lecture is actually the process towards Lagrangian mechanics. For Lagrangian mechanics, we will need a concept of virtual displacement because there our mechanics will be based on generalized coordinates. So we will introduce the concept of generalized velocity, generalized acceleration, generalized potential, and for these concepts we will require the generalized displacement. So first of all we will try to understand that what is this concept of of virtual displacement. So in this lecture, with the help of certain examples, we'll try to understand that what is virtual displacement. For that, first of all, look at the definition of virtual displacement, or you can say the concept of virtual displacement. It is change in configuration of a system as a result of any arbitrary infinitesimal change of a position coordinate consistent with the forces and constraints imposed on the system at a given instant of time. So there are certain conditions. If these conditions are fulfilled, then infinitesimal change in the position, that means there your object will be at some point at a time, and then without changing the time, if it moves to another position under certain conditions, then that displacement is called virtual. Now what are these conditions? The condition is that, the first condition is that the forces of constant should be same. Second condition is that the constants should be same. When your configuration is changing, that means you have first arrangement, you have one arrangement, and then you have some another arrangement of that object. So in that change, your constants should remain same, your forces of constants should remain same, and this all should happen at a given instant of time. That means there is no change in time. So if these three conditions are fulfilled, then only we say that the displacement is virtual displacement. So first of all, we'll try to uh, understand it with the help of an example of a simple pendulum. Right. In this simple pendulum, this is our arrangement of pendulum. Okay. This pendulum is moving to and fro, and if it is moving, suppose it moves and it comes to this position, this bob moves and it attains its maximum position, it moves backward and it attains this position, then naturally this is the change in the configuration. So we are saying change in the configuration of a system. So this is first arrangement and this is second arrangement. This is first configuration, this is second configuration. In this change, what happens? If I look at this first configuration, what are the constants? Suppose this is the position xy at some instant, then naturally x square plus y square is equal to L square. This is the constant because L is fixed. So this is a holonomic type of constant. This is scleronomic type of constant. This is unilateral constant, right? And then what are the forces in this first configuration? T, the tension force in the string, then components of mg, mg cos theta along the string and mg sin theta perpendicular to the string. These are the forces. Now what happens when this bob moves from this position to this new position? In this position, it moves through a distance delta theta. This is the angular distance. It was its position, which is represented by, say, Ri. So this is the displacement, infinitesimal displacement. So it is represented by linear displacement. This is delta Ri. And during this displacement, its mass remains same. Its component, what happens to its components? Because now this angle of inclination of this pendulum with this vertical line is theta minus delta theta. So what happens to the forces? First of all, I am talking about the constant, because L is fixed, so x square plus y square will remain L square. But still, if I write it in terms of theta, then what will happen? X will be L cos theta minus delta theta and y will be L sin theta minus delta theta. Similarly, if I talk about the forces, my forces will be T will remain the same, mg cos theta minus delta theta, mg sin theta minus delta theta. So you look at the forces, these forces and these forces, you look at the constants, though this constant is same. So you can say that the forces have been changed. While the condition of virtual displacement is that forces should not be changed. So in this case, again there is no virtual displacement. Secondly, you can also imagine that if one particle is moving from one position to another position, that will also take some time. So time is also changing, time is also moving. So here it is a case of no virtual displacement. Right? Now we come to another example to understand this concept. In this case, we are having uh, just a minute. Yes, we are having two masses. These masses are tied to each other with the help of a string. This string is massless and these are moving with the help of this pulley. Now this is the first configuration. This is first configuration. In this configuration, there is an inclined plane on which this mass is moving, and this plane is inclined at an angle theta. So you see that because this is the surface of contact to this mass, therefore there will be constant force which is imposed due to this surface. As I told you earlier that constant force work in normal direction, so this N is the constant force. Another force is m2g cos theta in opposite direction to N, and then m2g sin theta in the direction of surface, or you can say in the direction of the movement of this mass m2. So what are the forces? Forces are tension in the string, force is N, then m2g cos theta and m2g sin theta. These are the forces. Now we come to the second situation in which this mass is moving. This was the first position of the mass and this is the second position of the mass. This was the first position of this mass m1 and this is the second position of this mass m1. This mass is moving in the downward direction, so naturally this mass will move in the upward direction. So the same, because the string is inextensible, the same displacement will occur for the two. If it is moving this distance delta r, naturally this will be same. This is also delta r. So whatever will be the change in the surface, in the tension in the string, that will be adjusted because of these two. Here T is in this direction while delta R is in this direction, and in this case T is in this direction and delta R is also in this direction. So this will be adjusted, no problem. Now we come to the other forces. N will remain the same because theta, the inclination of the surface, is same. So the components of this m2g will remain m2g sin theta and m2g cos theta. So forces are same. As in the first situation, same in the second situation. Now what about the time? Because when this mass will move from this position to this position, naturally it will take some time. Or otherwise, if it is moving from this position to this position, it will take some time. So time is happening, time is moving. So again, this is the case of no virtual displacement, because it is violating the condition. Then what is virtual displacement? To understand it, we will take another example. Again, this is an example of a simple pendulum. Here there will be the two observers who are observing the motion of this pendulum in two different spaces. One space is on earth, that means in two different frame of references, or you can say from two different places. How? Their location is different. There are two observers. One is observer X, one is observer X, and another is observer Y. One is observing the movements of this pendulum from earth, and another is going to space with the speed of light and observing the motion of the pendulum. Both have the same time, both have the fixed time, like both have the time of 2 seconds, say. In 2 seconds it is observing, X is observing, and X sees that there are two oscillations in 2 seconds. After 2 seconds, Y comes back as per Y. Y को 2 सेकंड दिए गए हैं, वो अपने हिसाब से 1 सेकंड में गया है और 1 सेकंड में आया है, जैसे भी गया उसने 2 सेकंड कवर किए. And when he comes back, he says that there are two oscillations in 2 seconds. But X observer is on earth. He says, no, you took 4 seconds of time. क्यों? क्योंकि टाइम डायलेशन हो गया. टाइम डायलेशन का मतलब एक डिफरेंस हो गया टाइम में. क्यों हो गया डिफरेंस? क्योंकि दोनों का जो पोजीशन है, ग्रेविटेशनल पोजीशन है, वो फर्क थी. ऐसी स्थिति में क्या होता है? टाइम डायलेशन हो जाता है. टाइम डायलेशन इज अ डिफरेंस इन द लैप्स टाइम measured by two clocks, either due to them having a velocity relative to each other or by there being a gravitational potential difference between their location. In this case, there was the difference in the locations. तो टाइम डायलेशन का मतलब ये कि y को लग रहा है मैं 2 में आ रहा हूँ, जबकि वो 4 सेकंड ले रहा है. अब हुआ क्या? x ने देखे 2 सेकंड में 2 ऑसिलेशन, तो उसने उनको ड्रॉ कर दिया. ऑसिलेशन का मतलब पोजीशन ऑफ थीटा बदलती रही, थीटा एंगल चेंज होता रहा. तो हमने एक ये ले लिया एक्स एक्सिस जिस पर हमने टाइम दिखाया है, और ये वाई एक्सिस जिस पर थीटा दिखाया है. थीटा में चेंज कैसे हुआ, उस चेंज को पूरा हमने प्लॉट कर दिया कि एक ऑसिलेशन हुआ 1 सेकंड में और फिर एक दूसरा ऑसिलेशन हुआ दूसरे सेकंड में. ये है एक्स ऑब्जर्वर के लिए. वाई ऑब्जर्वर भी कह रहा है कि नहीं, 2 ही हुए, 2 ही ऑसिलेशन हुए, पर उसका एक ऑसिलेशन 2 सेकंड में पूरा होगा, 1 सेकंड में पूरा नहीं होगा उसका. तो वाई का एक ऑसिलेशन कैसे पूरा होगा? ये वाई का ऑसिलेशन हुआ, ये y का ऑसिलेशन है, ये y का ऑसिलेशन. 2 सेकंड में एक ऑसिलेशन पूरा हुआ. उसके बाद एक और ऑसिलेशन, उसने भी 2 ही ऑसिलेशन ऑब्जर्व किए, उसका दूसरा ऑसिलेशन, ये 3 सेकेंड, अभी आधा हुआ है ऑसिलेशन, और फिर और आगे चला गया ये यहाँ पर 4 सेकेंड, राइट। दोनों के ही 2 ऑसिलेशंस। थीटा की क्योंकि मैक्सिमम वैल्यू दोनों के लिए सेम है, इसीलिए वो ऐसे ग्राफ बना कि थीटा की मैक्सिमम वैल्यू सेम होगी। अब हम किसी एक टाइम पर ऑब्जर्व करते हैं कि क्या होता है। हमने एक यहाँ पर टाइम कोई सा प्लॉट कर लिया, कोई सा एक टाइम कंसीडर कर लिया, और मैंने कहा सपोज इट इज t इज इक्वल टू 1.2 सेकेंड। इस पर हमने देखा कि दोनों के हिसाब से थीटा कितना है, यानी कि थीटा में चेंजेस कितने हुए, थीटा की क्या वैल्यू है। तो इसको मैंने यहाँ ड्रॉ किया, और यहाँ ये है, थोड़ा सा टेढ़ा बन गया है, थीटा इज इक्वल टू थीटा 1, और ये है theta is equal to theta 2. So there is a difference in theta. This difference in theta is delta theta. Delta theta is the angular displacement. So you see, time is fixed 1.2, but there is the angular displacement. Here the forces are same because the pendulum is same, constraints are same, configuration is in this configuration of न चेंज हुआ फोर्सेस में, डिस्प्लेसमेंट हो रहा है लगातार, लेकिन ना तो फोर्स में चेंज हुआ ना कांस्टेंट में चेंज हुआ, डिस्प्लेसमेंट भी हो गया और टाइम में भी चेंज नहीं हुआ। सो दिस इज एन एग्जांपल ऑफ वर्चुअल डिस्प्लेसमेंट विच इज एन इमेजिनरी कंसेप्ट, क्योंकि ऐसा हो नहीं सकता रियल लाइफ में कि कुछ काम हो रहा हो और टाइम स्पेंड ना हो, लेकिन हम ऐसा मानते हैं। मैथमेटिकली हमने एक डिफाइन किया ऐसा कंसेप्ट, और उसको हमने कहा कि वर्चुअल डिस्प्लेसमेंट, क्योंकि हमने कहा था ना पोजीशन में चेंज, Ri is representing the position vector, so change in Ri with this delta is called virtual displacement. ये जो symbol है ये virtual के लिए use होता है. It simply means there is displacement but under the condition that there is no change in time. Where this delta is very small, delta represents such type of displacement, is very small, such type of change which is very small. So this is the concept of virtual displacement. इसमें हुआ क्या कि हम ये कह रहे हैं फोर्सेस वही हैं, कांस्टेंट वही हैं, फ्रीज हो गया मोशन एक इंस्टेंट पर, और उस इंस्टेंट पर अब टाइम नहीं बदल रहा और मूवमेंट हो गया, टाइम नहीं बदला मूवमेंट हो गया, यानी डिस्प्लेसमेंट हो गया, तो वो हो गया वर्चुअल डिस्प्लेसमेंट, राइट। तो इस तरह से ये हुआ कंसेप्ट ऑफ वर्चुअल डिस्प्लेसमेंट। अब हम इस कंसेप्ट को यूज करेंगे for the concept of virtual work and then the D'Alembert principle. Thank you so much.